Hey guys, RK Coding here, and today we're going to be coding a Raytracer. Hey guys, in this video we're going to be making a Raytracer, and this is going to use C++ and SDL. And what a Raytracer basically is it's a 3D renderer, and basically you shoot a ray through each pixel of the image, and if it intersects any of the objects, you draw the pixel. Yeah, you draw the object's pixel, and then you like shade the pixel according to like the light source and stuff. And this is really slow because you have to shoot multiple rays for every pixel, and then you have to test the intersection of every object. But it allows for really realistic rendering, which is why it's used in like all animations and stuff. Because you can shoot a ray towards a light source and calculate if it's in a shadow or not, or you can calculate reflections by seeing if if you shoot a ray from the surface and sees if it reflects any object. So I spent a lot of time on this video. So if you like it, please like and subscribe. And I also have more graphics effects coming up. I spent like 7+ hours on this video actually. So the first thing I did was set up the Visual Studio project. And yeah, I just set up the basic source file, and I wrote the classic C++ Hello World program. After that, I downloaded libsdl, and I also extracted it and did all the stuff, moved it to my directory, renamed it, and after that, I started linking it. But first, I wrote some descriptions and license and everything. And yeah, I used all the linking settings for C++, and this is actually the hardest and most boring part of starting any C++ project. It's just long and time consuming and really boring. But yeah, so this is what I had to endure for the beginning of this project. And actually, I always have a hard time linking libraries, but it's something I'm getting better at. After that, I did the classic basic SDL program, as you can see here, and yeah, it worked great. Runs with no errors. Well, I did forget to return a value, but after that, ran with no errors. And then next thing I did was start working on a window class, and and it was pretty good. I've actually, this is a second take at a window class. At the first take, I had a weird pointer error, and it turns out I just needed to swap the X and Y position, and that's so annoying. It's so stupid of me, because if I had spent even the tiniest amount of time debugging, I would have figured it out, and I restarted and lost like a whole hour's work because I thought it was some weird memory issue and I would have to restart. And it just turns out I swapped the X and Y. But anyway, my window class just took a width, a height, and a title, and it had like an update function. And the way I was actually drawing pixels to the screen was I had a texture, and then I had a list of uint32s, like a pointer to an array of uint32s, and those 8 bits represents the A value, 8 bits represents the R value, G value, B value, and so on. But yeah, so you can see that I got the video to work, and I also defined some globals, and as you can see in my test code I wrote some globals, so basically the width and height. And then I should have started on my actual renderer and my drawing pixels to the screen, because for a Raytracer I need the ability to actually set individual pixels. It's actually kind of glitchy because I had Visual Studio running with the screen recorder with Discord, so I hope you can bear that in mind, but I think the video really turned out nicely, and it's one of my best videos. And actually, we're coming up close to the pointer error. And that will become apparent when I actually write the set pixel function. Right now I'm just writing the update function and also destroying all the pointers and memory I allocated for this program. And everything was actually working fine. And then the set pixel function. So as you can see here, you know, width times x plus y, it was actually y times width plus x. So that gave me like a really weird error when I actually used the set pixel function, which is I'm creating like a window full of random pixels. And this is my error, access violation. And this time I was like, I'm not restarting again, so I actually spent some time debugging it and you know, Googling all that stuff. And then after a while I looked at the reference I was using to write the pixels, and I figured it out, and I'm so dumb. Actually quite a while to figure it out, but bam, I switched it just now, and it worked like a charm. It actually works a lot faster when I'm not screen recording and running Visual Studio, but it still works pretty fast compared to other functions I used. And then after that, I started work on my vector class, which is integral to any Raytracer or renderer or like anything. The vector class, you can use it to store colors, and you can use it to store positions. So yeah. And this is just a lot of boring vector maths, honestly. Eventually I would set up my set pixel function to work with vectors, but right now I'm just actually writing all the operator overloads and stuff, like adding vectors, subtracting vectors, dividing a vector by a number, stuff like that. And I actually cramp it together in the very end, and I have everything like on one line. But like right now I'm just doing basic vector math. I've implemented a vector class so many times, because I've implemented like 5 Raytracers, each with like various different improvements, because whenever I want to like restructure my code, I just restart my project. So yeah, I'm pretty like accustomed to implementing a vector class. So yeah, here I am switching everything together. And actually what's annoying is the way style I have it is when I switch it together, I remove all the spaces in the operations, and Visual Studio's like, well, bruh, we're gonna auto format it for you. I also wrote a normalize function, because normalizing vectors is pretty important. So after this, I pretty much have a complete vector class, and I start working on actually a ray structure. Which is just an origin vector and a direction vector. Pretty much. I also start working on the very basics of a sphere class, and actually we're pretty close to getting a sphere. And this is what I like about Raytracers, and just like, I think this whole project was around 200 lines of code, and it took me like still 7 hours, mostly because of weird issues, but it's very simple. So I also started writing an intersection function, which took an array, which you test the intersection between the sphere and an array. And this is actually the only object I implement as a sphere. So you know the walls in like the image I showed you at the beginning of my Raytracer? Those are actually just scaled up spheres, and you can tell by some of the roundness. So yeah, I started writing an intersection function. And this part is actually very, very glitchy because I started opening up Minecraft, so it was just hogging on my resources. But like, you know, the code just jumps. But eventually I closed Minecraft. I don't know why I opened it in the first place in the middle of me recording. Not very smart of me, honestly. So here I closed Minecraft, so everything should be a lot smoother now. So now you can actually see stuff, me typing. And I'm here is the part where I set the set pixel function to work with a vector, and I was just naively casting it to a UN8 and thinking that would solve all my problems. But eventually I just converted it to an int because that works just as fine, and I actually had to clamp it to actually get my color function to work. But you know, if you're not, I'm not even sure if I actually ever had to do that, but you know, it did make smooth things up significantly because there was something odd with my colors, or it could have just been a bajillion other bugs because I ran into so many bugs in this program. I actually don't remember, but I knew I had to change it. And yeah, so I start working on testing, like I start making a list of objects, which is just all spheres, and I start making the actual meat of the renderer. I also have idle open like constantly because this is actually based off a Raytracer I did in Python that was kind of slow. And I had it so like you could show the process of the pixels being drawn to the screen, and it was so slow. It was even slower than my Python renderer. And actually, I skipped a lot of the part of me figuring out, but now you can see it instantly happening, and that's because I commented out the update function. And what that tells me is drawing pixels, C++ is very fast, and drawing pixels in this new method is very fast, but updating the texture is really slow, because, you know, it was really slow to draw a line across the screen, so updating it every pixel was not a smart idea. I like to do that so I could actually see the progress, but fortunately I couldn't. Anyway, I started implementing anti-aliasing with this global called sample size, so I shoot 32 rays for a pixel and offset them slightly, and then I blend together. And I was naively using the rand, because you have to offset it by a uniform value less than a pixel, so you don't actually get, so you still get like all the data in that region, but you don't get the next pixel's data. And I was just using rand, I was just using the random function, but C++ has like a dedicated random standard library, and I should have been using that, and I figured that out later. But I did get a really cool effect. When I set the rendering thing to offset by 100, you could really see like the blended effect I was going for, but very dramatized. See, I set it to 100 and you could see the blend together effect, but you know, it's just not working. So I was and then I realized I should implement random, so I do that very shortly actually. I think right about now I do it. So yeah, I should start implementing it very soon actually. Here we go, I implement random and I start implementing, I copied like distribution generator, and bam, it's a lot smoother. It isn't quite that smooth, but it's a lot smoother. And you can also see in the toColor function, I also added all the clamping stuff. And actually, I made a lot of changes off camera, and now I'm testing the color system, because I was actually, all I did was I added ambient spectral diffuse values to the sphere, and also I separated the intersection code and the rendering code, because those need to be separated. So yeah, the colors worked fine, so now is actually the time to implement lighting, which actually caused me quite a headache to implement diffuse lighting. And it turns out, I'll show you the issue later. here I am implementing my light structure, which is very important if you want lighting. Of course, you need a light structure. You need some kind of way to represent lights. It doesn't have to be a structure, it can be a class, or it could be like a list of values. And here I implemented the ambient lighting, which is the easiest to implement. And also I started working on my lighting method. I call it arcade method, and it's based on distance. So you multiply the distance and then you smallen the distance by a small value, and like if you look at it, it works really well actually. Like look at that, it looks 3D, and that's just one line of code lighting. And I also have like a small projection method that's also one line of code. So yeah, I commented it out because I'm using the Phong reflection model instead of my own that I thought up of, because this has a lot of limitations because it's based off distance. So you know, you can actually, because it's based off distance from the camera, so you can't actually move it. The light has to be coming from the camera. You can't have it in a different place. Here you can see I was just mapping by normals, and you could see it made a pleasant like green-red result. And then I started offering a lights list, of course, which I would loop over. And yeah, everything's working just fine. Until, of course, it wasn't, because apparently in the two light, like the direction to the light, it's supposed to be a normal, of course, because like directions and orientations are also always normals, and I didn't make it a normal. And actually in all the, see, you can see the lighting was kind of flat. It wasn't blending together very well, right? So it turns out that I had to make that a normal, and all my other things, like in all the other ray tracers, I never made it a normal. So for some reason I had to make it a normal for C++ or something. So I don't know, maybe like I was something was wrong. But here you see I made it a normal, and now it's actually diffusing properly. So now I actually need to get the value to look good. So yeah, I'm just trying different values, and you can see the slow changings. After a lot of trial and error, I think it took to actually get it to look good. But eventually I found the golden spot, and after I said everything right, voila, that looks perfect. After this, I actually started working on specular lighting, and I also set up a scene off camera, but you can see all the walls and stuff, and I started working on specular lighting, of course. And you know, after, I don't like the specular lighting. I never figured out how to get specular lighting looking good. So I just made everything diffuse, as you can see in the picture, but I did implement it, so you could theoretically use specular lighting. And also, you can't just, for some reason, because of pointer notation where you have to use the star symbol, it makes it really hard to do exponents because you need to use like a specialized function. Oh well, but it worked. I fixed it, and I used exponents to actually get it to more concentrated. And voila, specular lighting. It didn't look good, so I I tried to play with it a bit to make it look good, but eventually I just stuck with diffuse. Of course, diffuse. And, you know, voila! It's perfect. Obviously, this ray tracer isn't that advanced. It doesn't have textures, reflections, or anything. But I want to save the more advanced topics for when I make a path tracer. This video took me a really long time to make and a lot of time editing. So please like and subscribe. And we have a video on the star field effect and falling sand type effect coming up.